In this lecture here, we're going to continue talking in Chapter 1 by moving into Section 1.3. And this section is about models and applications. So really what you're going to see in this problem, or in this section here, is going to be about word problems. Now, I'm going to walk through like a five-step strategy here for word problems, but the key to word problems, the key to being really good at word problems is just practice, practice, practice. Like you get good at word problems by just doing them over and over and over and over and over again. And then you'll see as the more you practice these word problems, the easier they'll become. You'll be able to recognize, what I'm going to let the variable equal to, what my missing information is. And so it's just a practice, practice, practice. All right, so we're going to go through two objectives here. We're going to use linear equations to solve problems. So this is just these word problems. And then the final thing what we're going to do is we're going to solve a variable for a formula. And this I'm going to have two examples picked out at the end, and they're really, really straightforward. It's really, you're just going to take like a linear equation and just isolate one of the variables. It's pretty straightforward. Okay, so here's going to be our strategy, all right, for problem solving with linear equations. So this is going to be for solving word problems, okay? All right, so a model is a mathematical representation, excuse me, of a real-world situation. So we will use the following general steps, all right, in solving word problems. So the first thing you're going to do is you're going to let x represent one of the unknown quantities, okay? So it's going to be something like let x be equal to, and then you will define it, all right? Then in some of the problems you'll see here, there's going to be other unknown quantities. So what you're going to do is you're going to represent other unknown quantities in terms of x, okay? So you're going to have, in this case, it's going to be let a formula of x. It's going to be like x minus 5 or something like that equals. In step 3, you're going to write an equation in x that models the conditions. So this is going to be just some linear equation. You're going to solve the equation and answer the question. So just solve with the steps that we've learned. And then next you're going to do is you're going to check the solution in the original wording of the problem, not the equation obtained from the word. So this is just going to be a check. Like, does my solution make sense? All right, so all I'm going to do here is just work a bunch of examples here. All right, so here's the first one. The mean starting salary of a computer science major, okay, exceeds that of an education major by $21,000. So notice here that comp sci, what it is it's defined by the education major, right? It's saying it exceeds, all right? So that's more, so or you can think about it as an addition, by 21,000. Then it goes on to say the median starting salary of an economics major exceeds, so again there's that exceeds, so by more, exceeds that of the education major by 14,000. So look, your economics major, their salary or their median salary is defined by education salary. Okay, that's interesting. Combined, so when you combine all the salaries, okay, so when you combined the salaries of comp sci, economics, and education, all right, their salaries are $140,000. Okay, so determine the median starting salary of each: the education majors, the computer science majors, and economics majors, and this is just with bachelor's degrees. All right, so you're going to go through like this. Step 1, you're going to let x represent one of the unknown quantities. So what you don't know here is you don't know the starting salaries going back of comp sci, economics, or education. But all of them are defined in terms of education. Okay, so you're going to let x be equal to the median salary of an education major. Okay, so then next it says represent the other known quantities in terms of x. So if you look here, you notice how I wrote let x plus 21 be the median starting salary of a comp sci major. That plus there comes from the word exceeds, right? Because the comp sci major exceeds education major by 21,000. And I should also note here that it's in thousands. Then next we're going to let x plus 14, because an economics major exceeds an education major by 14,000, be the median salary of an economics major. All right. So the next thing you're going to do is you're going to write an equation in x that models these conditions. Now remember, it said that the salaries combined. So if you take the education major salary x plus the salary of the computer science major, which is x plus 21, and then you add to that the salary of the economics major, which is x plus 14, that should sum up and be equal to 140,000. In this case, just 140. So this you just have to solve, and it's like, look, it's a very easy linear equation to solve. So easier linear equation to solve. So you're just going to solve this. You're going to combine like terms, right? X plus x gets you 3x. 21 and 14 get me 35. So what you're going to do is you're going to subtract 35 over, right? So 35 or 140 minus 35 is 105. Then the next thing you're going to do is you're going to have 3x is equal to 105. Then you're going to divide by 3. And you're left with x is equal to 35. So what's going on here is we have the starting salary of an education major is x, which is 35,000. The starting salary of a computer science major exceeds that by 21, so 35 plus 21 gets me 56, so they're 56,000. And an economics major exceeds it by 14, so 35 plus 14 gets you 49. So their median starting salary there is 49,000. And then next, so you can see once you like have this set up right here, it really kind of falls into place. And so the next thing you can do to kind of like check this, just writing it in words here, right? So the median starting salary of an education major is 35,000, computer science major is 56,000, and economics major is 49,000. So to check here, just see if, the problem said it combined to 140,000. And if you add up all those numbers, 35 plus 56 plus 49, you do get 149,000. So it's definitely works here. Okay. All right, let's do another one. So you are choosing between two texting plans. Okay, here's another problem. You got these two. Now, I know everybody nowadays gets unlimited texting, but I'm going to date myself a little bit. It didn't used to always be like that. It used to cost money for each text. Like maybe it was 10 cents a text. And, we used to text our friends a bunch when we knew that, because some of us at that time had unlimited plans and they paid per text. But anyways, Plan A was a monthly fee of $15 with a charge of 8 cents per text. And Plan B has a monthly fee of $3, okay, with a charge of 12 cents per text. Okay, how many texts will the cost for the two plans be the same? All right. So we want to find out how many texts they'll be the same. Okay, so step one, what we're looking for, the unknown quantity. So we're trying to solve for the number of texts. All right. So what we're going to do is we're going to let x represent one of the unknown quantities. So we're going to let x be equal to the number of texts, because that's the unknown value we're trying to solve for. And so what are the other two things the other unknown quantities? What we don't know is how much the costs of the plans are, okay? So how much the plans cost in total. So Plan A, so if you were to take 8 cents times the number of texts plus your fixed fee of $15, that's how much Plan A would cost. And Plan B would be 12 cents times x plus $3, okay? So now what we want to do is we want to write an equation that we can solve. And so what we want to do is find out when the two plans will be the same. So our equation is going to be setting the two plan costs equal to each other. So our equation here, what you're seeing, setting the plans equal to each other. All right, so all you're going to have to do then is solve this resulting equation. So it's 0.8x plus 15 is equal to 0.12x plus 3. So I subtracted the 15 over. Then what you're going to do next, you're going to subtract, because once you get the 15 over, so it's 3 minus 15 gets that minus 12. Then you're going to subtract, because you're going to get the variable to the other side, 0.12x. So 0.8x minus 0.12x is minus 0.4x. And then finally, you're just going to divide both sides by negative 0.04. So negative divided by negative cancels. And 12, if you were to plug this in your calculator, you would see that x would be 300. So it turns out that if you just send 300 texts a month, and if you were all like me, you know, that's not the case. You send a significant amount more. The two plans will be the cost the same. All right, so check the proposed solution and the original wording of the problem. Okay, this, you know, does it make sense? So if you look here, how much, you know, the problem asks how many text messages will the two plans be the same. So the cost of plan A for 300 texts, you know, if you plug 300 in there, is $39. The cost of plan B for 300 texts is also, when you plug that into the equation, is $39. So for 300 texts, the plan costs are equal, which verifies our problem's condition. So really just what's going on here and here, just to be more succinct about it and clarify, is you're plugging 300 into each equation. Okay. All right, let's do another one. So now this is an interesting one. This is about price reduction. So after a 30% price reduction, you purchase a new computer for $840. Okay. What was the computer's price before the reduction? So that's what they're asking you to find. Okay, they're asking you to find how much you bought it at 30% off. You know, so what is the cost before the reduction? So we're going to let X here be equal to the price before the reduction. Okay. So then, well, how much was the price after, or you know, how much was the price after the reduction here? Okay. So what you're going to notice here, this seems weird. You're going to have this problem. So X minus 0.30X. Okay. So you can also think of this as, you know, 0.7X if you want. You're going to see that goes there. But this is the price of the new computer. It was the original price minus, so what is a 30% price reduction? It's 0.3 times the original price. Okay. So this is a 30% price reduction. And here's what we need to know. We want to solve this now. The price of the new computer, which is X minus 0.30X, is equal to this $840. So now we just need to solve this. Okay. You can also see, you know, you can also skip ahead and recognize that, you know, if there's a 30% price reduction, you paid 70% of the price. Okay. So if you're going to see in the next slide here, when I go to solve this, you know, X minus 0.3X is just 0.7X. And then you're going to divide both sides by 0.7. And when you do, boom, you get $1,200. So the price of the computer before the reduction was $1,200. And so you can check this, right? So if you do this, if you take the $1,200 and you minus a 30% reduction, you do see that indeed indeed that the given price is the original wording of $840. So here's just a quick verification of it so that you can see it. All right, let's try this one now. All right, this is a little bit money involving interest. So you inherited $5,000, nice, with the stipulation that you have to, for the first year, with the stipulation that for the first year the money had to be invested in 2 funds, paying 9% and 11% annual interest. That's pretty good. That's really good, actually. How much did you invest at each rate if the total interest earned for the year was $487? So what we're going to do is we're going to let X represent one of the unknown quantities. Doesn't matter actually if you'd pick the 9% or 11%. So what we're going to do is I'm going to say, okay, I'm going to let X be the amount that I invested at 9%. Okay. So the other quantity is we don't know the amount that we invested at 11%. Okay. But if you know how much you invested at 9%, the amount you invested at 11% has to be the $5,000 minus that amount. Okay, so it's 5,000 minus X. So write an equation in X that models the condition. So I left this blank so we could actually write this one in here. So how would we do this, right? So we're getting 9%, so I'm going to change that to a decimal, of the X amount, plus we're getting 11% of the amount invested at 11%, and that total had to end up being $487. So we just have to solve this equation right here. All right, so solve the equation. Let's answer the question. So you can see I have the equation set up here. All you're going to do is you're going to distribute to solve. So you get 0.90x plus 11% of 5,000 is 550 minus 0.11x is equal to 487. You're going to combine like terms here. Then next here, when you do 0.9x minus 0.11x is minus 0.2. Then you're going to subtract 550. And then finally, the next thing you're going to do, so you get 487 minus 550 is minus 63. Then you're going to divide by minus 0.02. And you get x is equal to 3,150. So what exactly is that? Well, that's X. And so what was X? If you look back, that was the amount invested at 9%. So then how much did you invest at 11%? You take 5,000 minus this, you get 1,850. Right? So what you're seeing here is you should invest you invested, okay, 3,150 at 9% and 1,850 at 11%. So check if this makes sense, and if you do, if you take 9% of 3,150 and 11% of 1,850 and add those two together, you do get the 487. So this verifies that amount that you invested. All right, let's do this. I believe this is the last one here. Yep. Okay, so last word problem before we move into solving for a variable here. All right, so the length of a rectangular basketball court is 44 feet more than the width. So notice how the length is defined in terms of the width. Okay, notice that. So if the perimeter of the basketball court, okay, so the perimeter, notice you're given the perimeter, is 288 feet. So realize what a perimeter is. A perimeter is 2 times the length plus 2 times the width is equal to the perimeter. All right, what are the dimensions? Okay, so note length is defined in terms of width, excuse me. So we're going to let the variable x be the width, okay? Then that means the length is 44 feet more, so that's addition. So that's x plus 44 because it's the width plus 44. So that's the length. So then all you're going to do is you're going to go 2 times, in this case they wrote it as 2 times the width, so 2x, plus 2 times the length, so 2w plus 2l is equal to my 288. So all we have to do is solve this equation right here. So just distribute first. So you get 2x plus 88 here, then 2x plus 2x gets you 4x, so then you're going to combine like terms. So you get 4x plus 88 is 288. You're going to subtract 88. Then you get 4x is equal to 200, so then you're going to divide by 4. And you see here that x is equal to 50. So realize what that is. That's the width of the basketball court because that's x. So then what is the length? Well, it's x plus 44 gets you 94 here in this case. So the dimensions of the basketball court here, all right, are 50 feet by 94 feet. And they'll check to make sure that this makes sense. Indeed, it does. If you take 2 times 50 plus 2 times 94, that does get you the 288. All right, so this verifies the conditions here. All right, so now let's talk about solving a formula for a variable. So let's take that perimeter formula. So perimeter is equal to 2 times the length plus 2 times the width. And I want to solve it for w. So what you want to do is you want to get the w by itself. So you're going to subtract 2l from each side. So notice how they cancel here. So you get p minus 2l is equal to 2w. So now I'm going to rewrite this. I'm going to flip it around. 2w is equal to p minus 2l. Then look, you're just going to divide by 2. These 2's cancel. And you're left with w is equal to p minus 2l over 2. Now you can't simplify this. Like these 2's don't cancel, right? Not like that. So this right here is, you get the w by itself. Okay? So the width is equal to the perimeter minus 2 times the length divided by 2. So you just treat the other values as constants and you solve for the variable that it's asking you to solve for. All right, so let's try this one. P is equal to C plus MC, and you're going to solve for C. So you have to get the C by itself. So notice how you have C plus MC. So what you can do is you're going to factor out a C. So you get P is equal to C times 1 plus M. Now you can divide this by 1 plus M. So these cancel. And I'm just going to rewrite this. So you have C is equal to P divided by 1 plus M. And if you cross multiply here, you'd get back to what you had. So this worked. All right, class. I know this was, just 2 quick examples here of this, but, just treat it like you would a linear equation. Whatever the variable is, treat the other things as a constant.